Hello people, this is my first YouTube video and I'm gonna cover Kirchhoff laws today. So this Kirchhoff law holds a very high weightage when it comes to your board exams, CUET exams or any other competitive exams. So without any further delay, I think we should start the topic. So first comes the Kirchhoff junction law, and I think it's really very simple. Everybody knows it, but still let's cover it. So it states that in an electric circuit, the sum of the currents entering a junction must be equal to the currents leaving the junction. So right now from this figure mentioned below, we can see that I1 and I2 are basically the currents which are reaching towards junction A, whereas I3 and I4 are the currents which are moving away from the junction. So as per the above law, we can write an equation, and that equation would look like what? It looks like I1 plus I2 equals I3 plus I4. Clear? Yes. And this first junction law is basically based on the law of conservation of charge. So let's do an illustration to boost our understanding and to have a good practice of the first law. So this particularly is the question, and I think let's move to the solution part. So this is how it looks like. So students, in order to get I which is required, we have to first proceed in a sequential step. So let us assume a current I1 which is going from A to B, right? So at junction A, we can write the equation as 2 ampere plus 4 ampere equals I1. That's basically I1 is equal to 6 ampere from the junction law, right? Similarly, at point B as well, we can write the, according to the junction law, we can write I2 plus I1 equals 6 ampere, and that is because 6 ampere is reaching the junction B, whereas I2 and I1 are leaving the junction B. So with this, we are now in a state that we can surely find I. So let's name a particular junction C where current I2 and I1 are heading to and 2 ampere is leaving. So at junction C, we can write the equation 5 ampere plus I equals 2 ampere. So we'll get I equal to minus 3 ampere. Now, there's an interesting part right here. That's I1 equals minus 3 ampere. So what does this negative sign denotes? So people, this negative sign denotes nothing but the direction of current. So direction of current, although current being scalar, so it has certain direction associated with it. So now this minus denotes what? This denotes that the direction of current which is being showed in the diagram isn't the right one. The current won't be reaching the junction C. Instead, it will be leaving junction C. That's why it's minus 3 ampere. Clear? And now let's move to the second law, which is very fundamental and holds a very, very good weightage. And usually we get a 2-marker or a 5-mark question based on this. So let's proceed. So this states that the algebraic sum of the changes in potential, mind you, the changes in potential, not drop in potential, which you'll find in many books, but yeah, it's actually the change in potential across all elements in a complete traversal of an electric loop of a circuit must be zero. Must be zero, and this is based on the conservation of charge principle, right? Yes. So before doing this, I think there are certain sign conventions which everyone should be aware of. And the first convention is that is the change in potential in traversing a resistance in the direction of current is minus IR, while in opposite to the current it's plus IR. So it is very much visible from the diagram only. And second one is most important, that is the change in potential in traversing an EMF source from negative to positive is plus E, while the in opposite direction minus E, irrespective of the direction of the current as shown in the figure. So there you can see, irrespective of the traversing of direction of current, we are assigning plus E and minus E, right? And this will be more clear when we'll do an illustration, right? So, but now Let's write an equation for this given loop as for the Kirchhoff's loop law. So we'll start from loop A. So we'll move in this loop. This A, B, C, D, and back to A. So we can write potential at A minus IR1, this minus IR1 because we are moving in the direction, in the assumed direction of current. So basically it will be minus IR1, then now plus E1, and then this is very interesting, that is plus I2R2, and that is because we are moving in the direction opposite to the direction of the current in that branch. And then again minus E2, which is very simple, and then we'll reach junction point A, right? So we can write the same equation as minus IR1 plus E1 plus I2R2 minus E2 equals to 0, right? So let's do a few illustrations on this, which will boost our concept and understanding of the topic. So now, this is a really easy sum. There is only one loop. So we will be moving from B, C, D, A, B, right? Let's move. So while traversing in this direction, we will first encounter a resistance. So while traversing through the resistance, there will be a loss in potential that will be equal to minus 2I. And then again, there's a loss in potential that's minus 15. And again, minus I. And now we'll gain, that's a gain of potential of plus 20 volts because we are moving from negative terminal to the positive terminal of the battery. And then again, there's a loss of minus 4I potential. Then again, minus 10. And then again 3, and then that's again of 30 volts and equals to 0. So after solving the above equation, all we'll get is 10I equals to 25, which gives us I equals to 2.5 ampere. This means the current in this circuit is 2.5 ampere. Great. And this is a really good question. In the circuit shown in the figure, find the potential difference between point B and E. So now it's a really interesting question. They have asked us to find the potential difference between point P and E. So how are we going to find that? In order to find that, we'll have to first find out the current because the current will help us. And now, so let's assume that I1 is the current that is coming, that is flowing basically. And then at junction F, the current is getting divided. The current that is moving along the path F to A is I2, and from path F to C is I minus I2, right? So using Kirchhoff loop law basically, in the loop A, B, C, F, A, we can write that there is a loss of potential of minus 2 volt. That's basically because we are traversing from higher potential to lower potential of a battery. And then again, there's a loss of minus 2 I2. And then again, now there's come an interesting point. We are moving in the direction opposite to the direction of current in that branch. But still, as we have discussed back in point 2 of our sign convention, and there was this, that irrespective of direction of traversal of current, we're gonna assume the potential gain, right? So here there'll be minus 4 volt, there's a loss of minus 4 volt, and then there's again minus 4 I2 loss in potential, and we'll equate it with 0. So we'll get 6 I2 equals to minus 6, and then I2 equals minus 1 ampere. And yeah, that's again a negative sign. So negative sign denotes that the direction which we have chosen in the loop A, B, C, F, A will not be the right direction. It will basically, the current will flow in the direction opposite to the direction which we have assumed. That is the opposite to the direction of I2. Okay. So similarly, traversing in loop C, D, E, F, we can write minus 4I1. That's very much clear. Then there's plus 6 volt. That's a gain of potential. Then minus 2I1 because pretty much simple reasons. And then there's a gain of plus 4 volt as we're moving from negative to positive terminal of the battery, and we'll equate it with 0. So 6I1 equals 10 and I1 equals 5 upon 3 ampere. So this is actually the correct direction because because the current is coming out to be a positive 5 by 3 ampere. And now since we've got I1, I2, so we can easily figure out what is the current in the branch FC, and that is nothing but 8 upon 3 ampere, right? And it is pretty much simple. You can make it out. 5 minus 3 minus 1, which will be 5 by 3 plus 1. That's simple. Now we are in a state where we can evaluate the potential difference between point P and E. So we can move in any direction we choose, that is from B, A, F, E or B, C, D, F, E. So now let's move in the direction B, C, D, E. So potential at B minus, so potential at B plus 2. And now there is the plus 2 right here, which you see is because, which that is because the current in BC branch is, because we are moving from B to C, but the current in that branch is actually from C to B. That is because of the negative sign which we have obtained in minus 1 ampere, right? So there will be a gain of plus 2 volts, and then that's again minus 4 into 5 by 3, as that is in the direction in which we are moving. And then that's again a gain of plus 6 volts, which is equal to VE. Now VB minus VE by simple mathematics will obtain is minus 3 by 4 by 3 volt. So this is how you can crack such questions. And trust me, people, these are really very easy questions which we can do based on the Kirchhoff law. And the Kirchhoff law is really very important. So I hope you like this video. So until then, please share, subscribe, and like.